So in this video we're going to show a couple of interesting techniques, and one thing to keep in mind is that there's nothing wrong with using algebra to make your life a little bit easier. So two things going on here. Number one, we want to find the equation of a tangent line to a graph of a function. So anytime you want to find the equation of a tangent line, you need to find the derivative because you need the slope of the tangent line. The other thing here is our numerator has a fraction in it, so this is a complex fraction. So we can definitely simplify this before we start trying to use a rule on it, otherwise the derivative could get pretty nasty pretty quickly. So the first thing that I'm going to do is I'm going to take my function f of x, which is 2 minus 1 over x divided by x plus 7, and in order to clear those fractions, I'm going to multiply this by x over x. That's perfectly legal. So that makes 2x minus 1 divided by x squared plus 7x. And that's a lot easier to take the derivative of using the quotient rule. So my f will be 2x minus 1, and my g will be x squared plus 7x. So f prime is going to be 2, and g prime would be 2x plus 7. So I know the slope is going to be f prime of x at the given x. So that's going to be g f prime minus f g prime divided by g squared. And in this case, that will be x squared plus 7x times 2 minus 2x minus 1 times 2x plus 7, all divided by x squared plus 7x squared. And then I could distribute 2x squared plus 14x minus, if I FOIL that out, I get 4x squared plus 14x minus 2x minus 7. And this is all going to be divided by x squared plus 7x squared. And I am going to go ahead and distribute this negative and simplify. So that gives me negative 2x squared plus 2x, because I've got 14 minus 14 plus 2, plus 7, all divided by x squared plus 7x squared. So this is a formula for the slope, and if I want to find the slope, I'm just going to plug in the value of x. So in this case, x equals negative 1. So my slope, m, is going to be f prime of negative 1, which is negative 2 times negative 1 squared plus 2 times negative 1 plus 7, all divided by negative 1 squared plus 7 times negative 1 squared. So that gives me negative 2 minus 2 plus 7 divided by 1 minus 7 squared, or 3 over negative 6 squared is 36, which is 1/12. So I've got a slope of 1/12, and I've got a point negative 1, 1. So I'm going to plug that into my point slope form. So I have y minus 1 equals 1/12 times x minus negative 1. Y minus 1 is 1/12 times x plus 1. So y minus 1 equals 1/12 x plus 1/12. And if I add 1, I get y equals 1/12 x plus 13/12. So this is the answer that I wanted from all of that work. This is an example of a problem that you could work with the quotient rule. Nothing wrong with that. I would probably distribute the negative 2 on top first. But you could also work it without the quotient rule if you choose to. So an algebra technique that would make your life a little bit easier. We're going to go ahead and distribute and make that negative 6x minus 14x squared divided by 5x. And then because this has a monomial on the bottom, you can make this negative 6x over 5x minus 14x squared over 5x. And notice some of your x's are going to cancel. So you end up with negative 6/5 minus 14/5 x. Now we haven't actually done any calculus yet. When we go to find the derivative, that derivative, that's going to be the derivative with respect to x of negative 6/5 minus the derivative with respect to x of 14/5 x. So that's going to be 0 minus 14 over 5, or just negative 14/5. So again, you can use the quotient rule here. You'd end up getting the same answer, but it's a lot easier to use the algebra first. This is a similar problem where you may be tempted to use the quotient rule, and you can. You would just have to let f be equal to 9 and g be 4x cubed. So f prime would be 0 and g prime would be 12x squared, and then you would follow the rule from there. That's one way to do it. Or, if you want to make your life a little bit easier, we could make this 9/4 times the derivative with respect to x of x to the negative 3, because remember we can bring that up across the line and change the signs. So that's just 9/4 times negative 3x to the negative 3 minus 1, or negative 27 over 4 x to the negative 4, or negative 27 over 4x to the 4th. So either way is fine. I think this is a little bit easier, but if you want to use the quotient rule on that, there's no problem with that.